In section 9.5, we're going to talk about the effects of changing dimensions proportionally. So if you look at the right, you will see that in these DVD shipments, the height of each DVD is used to represent the number of DVDs shipped per year. However, as the height of each DVD increases, the width also increases, which actually causes a misleading effect. So let's start with what we're talking about today, and that is the effects of changing the dimensions. All right, so let's look at example number 1. I want you to draw this picture, and once again, as you're taking these notes, you should either be taking screenshots or writing this in your notebook. So describe the effect of each change on the area of the given figure. The height of the parallelogram is doubled. Whenever you're given something, even if you have numbers or not, make up your own numbers if you don't have them. Otherwise, actually calculate what we're talking about. So we're calculating base times height, area of a parallelogram. So 12 times 9 is just going to give us 108 centimeters squared. So we want to know what happens if the height of the parallelogram is doubled. Well, we're going to double the height. 18 times 12. 18 times 12 gives us 216 centimeters squared. So what is the effect? The effect is that if the height is doubled, the area is also doubled. Part B, the base length of a triangle with vertices 1, 1, 6, 1, and 3, 5 is multiplied by 1/2. Step 1, draw the picture. As you draw the picture, you can also calculate or draw in the height. So here's our picture. So we're talking about what? Well, if the base length of the triangle with vertices is multiplied by 1/2. So how would this affect it? Well, the area right now is 1/2 base times height. So that's going to be 10 square units. So 10 square units. So we multiply the base by 1/2. Well, that's now going to be 2.5 or 2.5 multiplied by 4. And that's going to give us an area of 5 units squared. So if the base is multiplied by 1/2, then the area is also multiplied by 1/2. Now, I can't stress enough how much I can tell you is just plug in numbers. Actually figure this out if you get confused. So example 2, how do we change something proportionally? Now this is not just changing one dimension, it's describing the effect of each change on a perimeter or circumference and the area of the given figure. So in A, the base and height of a rectangle with base of 8 and 3 are both multiplied by 5. So what happens on the perimeter for circumference and the area? So let's find the perimeter first. So we have a base and height of a rectangle of 8 and 3 meters. So the perimeter would be 22 meters. And the area would be 24 squared meters. If we multiply both of them by 5, do you think the perimeter is going to be multiplied by 5? Do you think the area is going to be multiplied by 5? What do you think? Well, if we multiply them by 5, that gives us new values of 40 and 15. So that gives us a new perimeter of 110 meters and a new area of 600 square meters. So what do we know? Well, the perimeter is multiplied by 5. But the area is multiplied by what? Well, the area, since it's squared, the area is multiplied by 5 squared, or 25. Part B, the radius of circle A is multiplied by 1/3. So we're going to draw a picture. Actually, this is part of the problem is the picture, but I did not put it down here. So let me put the picture here, and there it is. So we have our circle. So A equals, the first thing is don't plug anything in for pi, just leave it the way it is. So the area is going to be 81 pi inches squared, and the circumference is just 2 pi times the radius, so this is just going to be 18 pi inches. Now if we multiply by 1/3, the new radius is 3 inches. So that gives us an area of 9 pi squared inches and a circumference of, let's see, 2 times 3, which is 6 pi inches. So what do you know? The circumference is what? Well, the circumference is multiplied by 1/3 and the area is multiplied by 1/3 squared, or 1/9. So when all dimensions of a figure are changed proportionally, the figure will be similar to the original figure. Huge, important thing to note. If they are changed proportionally, the figures will be similar. Now, in example 1, we only changed one of the dimensions. Therefore, we did not change it proportionally. So if you change all of the dimensions proportionally, then all dimensions will be multiplied by A. So if you're changing the dimensions by all dimensions multiplied by A, then the perimeter and circumference will be changed by that same factor, and the area would be changed by a factor of A squared. We just proved that in example 2. So in example 3, effects of changing area. A square has side lengths of 5 centimeters. If the area is tripled, what happens to the side lengths? Well, the area we know is 25 squared centimeters. If we triple that to 75 square centimeters, and we need to find the side length, so s squared, base times height, or side squared, equals 75. We take the square root of both sides, and the square root of 75 gives us 5 root 3. So we know the side length is 5 root 3. So here, the side length was what? Well, the side length was 5 centimeters. Here it's 5 root 3. So what happened? Well, the side length is multiplied by root 3. So let's look at our next example. A circle has a radius of 6 inches. If the area is doubled, what happens to the circumference? So if we have an area, and right now, the area will be r squared, so 36 pi squared inches. Double it. All right, so that gives us 72 pi squared inches. Well, the original 36 pi and the circumference, now we did this in circumference, we can't forget that. The circumference would give me 2 pi r, so that'd be 12 pi inches. Well, we have to find the radius, so I'm going to take A equals pi r squared. I'm going to plug in my 72 pi equals pi r squared. That gives me r squared equals 72. And the square root of 72 gives me 6 root 2. So now I have to plug that in and find my circumference. So circumference would be what? Well, if I multiply it by 2, I get 12 root 2. pi inches. So what happens from 12 pi to 12 root 2 pi? Well, the circumference is multiplied by root 2. And voila, there's my answer. Our last example is about an applicational problem. It says that the graph shows that DVD shipments totaled about 182 million in the year 2000, 364 million in 2001, and 685 million in 2002. The height of each DVD is used to represent the number of DVDs shipped. Explain why the graph is misleading. Well, when I look at this, I see that this is the height, which is also the diameter. But we're going to call that the height of each DVD. But if I'm looking here, this is about 685 million, and this one's about 182. If you divided them, it looks like from here to here, it's approximately 3.8 times greater as the number of CDs, which it is. So this is 3.8 times bigger. However, that means the area of the DVD is multiplied. Now the area, remember, if we change the diameter or change the radius by multiplying by 3.8, going back to what we did, the area is going to be then 3.8 squared times bigger. So, which is approximately 14.4 times the area of the small DVD. Well, why is the graph misleading? Because it's making us seem that this area is about 14.5 times bigger than this one. But the graph actually indicates that it's actually only closer to about 4 times as great. So right here, the graph gives misleading impression that the number of shipments was more than 14 times the number in 2000. But it was actually only about 4 times the number shipped in 2000.